Hi, in this video we're going to continue working with polynomials. In the last video I introduced polynomials, explained that polynomials are single terms separated by plus or minuses. We've got several different specific types of polynomials here. Monomials are a single term, binomial have two terms, trinomial have three, and then polynomials we don't identify specific types beyond the three terms. But notice each of these terms are separated by a plus or a minus sign. We talked about like terms. We recognize that like terms have the exact same exponent makeup. We continued on collecting like terms by collecting the coefficients out front. But here we have an example where we have two different terms here that have different variable exponent situations here, but so they are not like terms. We could not collect them. We went on to talk about what do we mean by collecting. When you're collecting, you're adding the coefficients or collecting the coefficients, that whole number factor of the term. It has to make sure that we are only collecting those that are like terms. So we practiced adding, where here I circled two of them that were like terms so we could collect those coefficients out front, because 4 minus 2 is 2. That collected to give us 2x cubed. Same thing here, we had 2x plus 5x, that collected to give us 7x. We went on to do subtracting polynomials. We had to make sure that, actually what we saw here is that our polynomials were then given to us in parentheses to further detail so that we'd know what it is that we were subtracting from what. That's basically the whole purpose of the parentheses here, is just to group which polynomial is to be taken from the other. So, but when we did this, we had to distribute a -1 throughout that second term, or that second polynomial, so that we were subtracting each of those terms. Once we did that, it was just a matter of collecting like terms. Okay, so that was the operations of adding and subtracting polynomials. The next part of that video, we went into talking about multiplying polynomials, and we started out with very basic multiplying monomials, and I'm going to review the first two steps just because they are so important that you keep them straight. We look at the coefficients on the baseline. We can actually carry out that multiplication. Like before, when we were adding, we went ahead and added those coefficients. Because we're multiplying polynomials here, we're going to multiply those whole number coefficients out front. So 3 times -5 gives us -15, but now we've got to kick in our exponent rules. What do we do when we're multiplying exponents? So we have x times x. We have to remember that this is an implied to the first power. When we are multiplying exponents, we add the powers there. So this would come out to be x squared. In this case, we have like a negative invisible 1 there and an invisible 1 here. So we're saying -1 times -1 is going to give us positive, but then x times y is just xy. We can't put any squares on this because these are separate variables. Here we have -x squared times x cubed. This is going to have a negative outcome. I could write the -1 if I wanted to, but I'm just going to imply. But I'm taking my x squared times x cubed. This is where I add my exponents. So this becomes x to the 5th power. If you are struggling with that, you probably want to go back and review the video on exponent rules. 3 times 4 is going to give us 12. That's multiplying those coefficients because they're on the baseline. Then we're hopping to our exponent rules. This would come out to be x to the 7th because we're adding those powers. 4 times -2 is going to give us -8. Y to the 5th times y to the 6th would be y to the 11th. Continuing on, we're going to take a look at what happens when we multiply a monomial, in other words, a single term, by any other kind of polynomial. And this is kind of a new phenomenon. We've not had this before up until this point. I'm going to be looking at saying x times this binomial in here. And before, when you saw those parentheses, you probably are recalling PEMDA rules that you need to complete what's inside the parentheses. And you are right on target, except when I look inside my parentheses here, there is absolutely nothing I can do. I just can't collect those because they are not like terms. So now I have to back out of this and recognize that these parentheses are communicating multiplication. And I'm going to have to use the distributive property. In other words, take this monomial out here and multiply each term inside the parentheses by that monomial. So x times 2x is going to give us 2x squared. X times 4 is going to give us 4x. Similar scenario going here. I have to distribute 2y times y is going to be 2y squared. 2y times 7 would be plus 14y. In this case, I'm distributing a little more complex monomial here. X squared times x is going to be x to the third. X squared times a negative 6 is going to be minus 6x squared. And here I'm taking a monomial and I'm distributing it to 3 terms, in other words, a trinomial. So I have to start with my coefficients. 3 times 5 is going to be 15, and now I'm going to dive into my exponent rules. X squared times x squared will be x to the 4th. Remember, I have to collect or add those exponents. 3x squared times negative 6x is going to be 3 times negative 6 is going to give us minus 18. X squared times x would be x to the 3rd. 3x squared times 8 is going to be positive 24x squared. Now if you notice when I was speaking through this, I said 3x squared times the negative 6x. I started with my coefficients. 3 times negative 6 is negative 18, and then went back and worked on my exponent rule. So I'd really encourage you to break it up that way so that you can stay on target. Okay, and then we are going to move into the scenario where we are multiplying 2 monomials. All of the examples that I have on this page here are going to actually be 2 binomials. And so it's a little more involved. You're going to think of distributing the first item in the first set of parentheses to each item in the second set of parentheses. Once you've done that, then you're going to take the second item in the first set of parentheses and distribute it to everything in the second set of parentheses. So I had a student one time who kind of named this rainbows and scoops, and I've kind of used it ever since because every student seems to pick up on that pattern. So d times d gives us d squared, and d times 5 is going to give us plus 5d. 8 times d is going to give us plus 8d, and then 8 times 5 is going to give us 40. Now if we look at this really closely, it looks like when you multiply a binomial times a binomial, we're going to end up with 4 terms. But if you look a little more closely, those 2 middle terms are very often 2 things that we can collect because they are like terms. Not always, but in this case, on this page, they definitely will be. So I bring down that first term, d squared, because I can't collect it with anything, and then collect my 2 middle terms here. Okay, and this next one, again, I'm going to draw my rainbows and scoops just to keep me on target so they don't forget anything. 5m times m is going to give us 5m squared. 5m times negative 4 is negative 20m. 3 times m is plus 3m. And 3 times negative 4 is negative 12. Go to collect my middle terms here. 5m squared minus 17m minus 12. Okay, rainbows and scoops again. So 2p times 3p will give me 6p squared. 2p times negative 5 is going to be minus 10p. Negative 3 times 3p is going to be negative 9p. Negative 3 times negative 5 is going to be positive 15. I'll collect my 2 middle terms. So we'll have 6p squared minus 19p plus 15. So this really pulls a whole lot of skills into play. When I started throwing some negatives in here, you could see that you've got to be aware of your rules when you are multiplying positive and negative numbers, and then you're switching back to collecting negative numbers. So you have to have all your operations down with negative numbers, positive and negative numbers. And then we're going to move on, and you're going to see that you're going to get back into having to really employ your exponent rules as needed.